Okay, so in this video we're going to learn about vectors. So let's say we have x and y. So vectors is just another way to represent x and y in a different format, which is x and y. So always the upper one is always the y movement, and then the lower one is the lower movement. So now let's start with positional vector. What is a positional vector? So a positional vector is a vector that starts at the position, which is the origin of the Cartesian plane, and then it goes some direction towards a certain point. That's a positional vector. So if you have a vector that starts at the origin, which is origin O, and then it goes to a certain point or a certain distance, that is a positional vector. So we can easily work out a positional vector. Let's say this is represented by letter A, and then this is represented by letter B, and then this is C, and then this is D. So note that I'm underlining the vector to represent. You can sometimes put it at the top. Most of the time they put it at the top. I prefer it at the bottom to just prefer that it's bold. Okay, so now let's say we have some calculations. These are basic calculations regarding vectors. Let me just flip this one. So if you do some basic calculation regarding vectors, you have, let me say you have 1 is to 2 plus 3 is to 4. So in this case, this is adding the vectors. So you just add the x and x. X is 4, not divide by. This is a mistake that people make, and I'm also making it, which is 6. So, okay, let's take the same vector. 1 is to 2 minus it, and then it's 3, 4. This will just give you -2 and -2. So basically, if you have something like that, then you can simply just minus them like that. But then what if you want to multiply them? So when you're multiplying vectors, you actually just do the same thing. It's x times x and y times y. Why is it so straightforward? Because I mean, when you get to the matrices, it will start being more interesting. But now you're still doing vectors. So now, okay, let's say you have some vector A equates to 1 is to 2. Let's say find the magnitude for A. Find the magnitude of A. So the magnitude of A is just for interesting sake, just plot your Cartesian plane to understand what the magnitude is. So you have 1 is to 2, so it is 1, and then it goes 2 units up. So you have 1, 2. So you have something like that there. So what the magnitude is just asking you what is the hypotenuse of this vector, or what is the displacement. So you just, this is 2 and this is 1, this is 2. If you draw a triangle there, so you have the hypotenuse will be given by h, let me just write h or a, equates to 4 plus 1, which is 5. Square root of 5 is just the square root of 5. So h will be just the square root of 5. So now this thing will be equates to the square root of 5. Okay, so now you're done with the vectors. For now, you got the magnitude, you got everything. But what does the vectors represent? Okay, let's draw our Cartesian plane again and just illustrate what does the vectors represent. So if you have a vector of 1 is to 2, it just goes 1 unit to the x values and then 2 units up. Okay, so it's 1 and 2. Okay, let's say you have a 5 is to 3. 5 is to 3 will go 5 units this side. 1, 2, 3, 4, 5 there, and then 3 units up. So you have a positional vector that goes like that. And then same with the negative, same with the positive in any other direction. Okay, moving on to matrices. So now we have matrices. Matrices most of the time represent a relationship between a certain object within a Cartesian plane. So let me say we have positional vector of 0 is to this is 3 and 2. Let's represent this thing on the matrices. We have 0, 0, which is a positional vector, and then it is which is 3 and 2. So these are the end coordinates, all right? So now let's say we have something like that. It's a positional vector, and then we represent it in matrices form. This is called 2 by 2, by the way. 2 by 2, so it goes 2 times 2. Okay, let's write a 2 by 3. A 2 by 3 would look like, let's say we have a line that goes down there that's going to represent that one. So we have 0 is to 0, 3 is to 2, and then we have 3 is to 0. Okay, so now that's a 3 by 3 matrices. Okay, let's say now we have a random point that we pick up at the Cartesian plane, and it looks like Cartesian plane doesn't look like a Cartesian plane, but anyway, let's say we have our triangle there. Let's say we know that this point is 1 and 3. This one, it is 3 and 1, and this one is 1 and 1. Those are the x and y values. So let's start here. Let's call this A, B, and C. So let's represent this thing in A, B, and C form. So this will be A was 1 and 3, and then B was 3 and 1, and 4 was C was 1 and 1. So this is a 2 by 3 matrix. So that's how you represent matrices. Matrices are representing a relationship within a certain object. Yep.